Very welcome to the Wandering Chemistry. And in the previous lecture, we talked about the types of elements on the basis of electronic configuration. And we have talked second type in the previous. Now let's see the third types. Transition element. The electronic configuration of their outer cells are given by a general structure in bracket n-1 into d sup minus 10 into n s sup 1 minus 2 1 to 2. They are termed d block elements. They are also known as outer transition elements. Now we would see the characteristic of transition elements. As in all transition elements, the ultimate cell of electrons is expanding. They resemble in their physical and chemical properties as given. First, metallic characters. These are all metal which are malleable, ductile and good conductor of heat and electricity. They forms alloys. Second, physical constants. These are heavy metals with high melting and boiling points. Zinc, Zn, cadmium, Cd and mercury, Hg have lower melting point because their subshell is complete. Third, reactivity. They exhibit a tendency to remain unreactive or noble. Fourth, color. Their compounds are usually colored. Fifth, variable oxidation state. They exhibit variable oxidation state. Sixth, magnetic properties. Most of these elements are paramagnetic because of presence of unpaired electrons in their orbits. Iron and cobalt are ferromagnetic and can be magnetized. 7. They generally form complex compounds. 8. They have tendency for forming alloys. 9th, they act as catalyst. And last, 10th property, their IP, ionization potential, or I, ionization energy is intermediate between S and P blocks. Now the fourth types of elements, lanthanides and actinides or inner transition elements. Lanthanides and actinides or inner transition elements. In these elements, the three outermost orbits are incomplete, that is F block elements, because they are anti-penultimate, that is third from the outermost cell, is being expanded 18 to 32 by addition of F electrons and includes rare earth from atomic number 58 to 71 and actinides atomic number 89 to 103. Their two outermost orbits are exactly identical to one another. The regular filling of 4f orbital is lanthanides and of 5f orbital in actinides accounts for their striking resemblances in most of their properties. Now see the bridge elements. The few elements of the third period of the periodic tables are sometimes known as bridge elements because they resemble with elements of A and B subgroup both. For example, magnesium is known as bridge element because it resembles with calcium 2A element and zinc 2B element. For example, magnesium resembles to CaSr and Ba, which is 2A element, and magnesium also resembles to Zn, Cd and Hg 2B element. Resemblance of magnesium with calcium. First, both are S block elements. Both have 2 electrons in the outermost orbit. Both form colorless compounds. And resemblance of magnesium with zinc. Magnesium salts give pink color in cobalt chloride test and zinc gives green color in cobalt chloride test. Second, Mg S sub 4 dot 7H sub 2O isomorphous with Zn SO sub 4 dot 7H sub 2O. Now let's see the typical elements. Mendeleev regarded elements with low atomic weight in each group, particularly the first element, as a typical element, but it is found that the first element in each group does not truly represent the behavior of other elements in the same group, and in fact resembles in many respects with the second elements in the next higher group. Thus the elements in the third series of the periodic table are from sodium to chlorine are known as typical elements. The remarkable features of these elements are they exhibit the properties of group such as valency, electrochemical character, etc. Diagonal it is relationship of few elements of second and third period of the periodic table. For example, group second period 1A lithium shows diagonal relations with Mg in third period, and 2A beryllium shows diagonal relationship with aluminium in third period, and 3A boron B shows diagonal relations with Si. Reason: one moving in a period, increase in ionic charge takes place with decrease in ionic size. This increases its polarizing power, while in a group, the increase in ionic size takes place giving decrease in polarizing power. Thus, on moving diagonally, these two opposite charge partly checks each other, making no marked change in properties. Now let's see the summary of types of elements in periodic table at a glance in a nutshell.